Alright, 6 quick examples that will bring out different aspects of this. These first 3 are super contrived. We're going to ask the question, how many color patterns are possible? We're going to color each square a color, and we have 5 colors to choose from. So what I want to bring out is the differences between these problems. In this version, each square could be any of the 5 colors. In this version, it's got to have horizontal reflection symmetry. So whatever the first 2 are, the next 2 have to be kind of reflections of the first 2. And then in the last one, each color must be different. We can't use the same color twice. So how would we apply the fundamental counting principle? For this one, where each square could be any color, there's 5 options for coloring the first square, and 5 for the next, and 5 for the next, and 5 for the next. So that's equal to 5 to the 4th power possible ways of coloring in these squares with colors. For this one, where it's got to have a reflection, I have 5 choices for this color. I have 5 choices for this color, but this color I don't have an option. This color has to be the same as whatever I chose here, so there's only one choice. Same thing for this one. This has to be whatever color that one was, so again, only one option. So here, there's only 25 possible ways of coloring in a strip that's going to be symmetric in this way. All right, what if all the colors have to be different? Well, this is just like asking how to permute a choice of 4 out of the 5 colors. I've got 5 choices for this square. I only have 4 color choices for this square because I've already used up a color in this one. And then 3, and then 2. And so that's like a permutation problem. All right, so that's something to think about is once you've broken it down into choices, think about how your options might change based on prior choices you've made. The next 2 pairs of problems are an example of the kind of thing I used to do when I did this in Algebra 2 trig. Let's read both problems before thinking about them. So if I have these lines to choose from, how many triangles are there in this picture? So for example, I see a triangle here on the inside, but I see this is a triangle. And like this is a triangle that goes to the outside there. So there's a lot of different triangles. All right, that's interesting. Let's read the next one. A casting director is auditioning 2 female actors and 3 male actors and 2 child actors. From these, she must hire one of each for the parts of a mother, a father, and a child. It's a very traditional problem. We're assuming that the part of the mother is going to be played by a female actor, and the part of the father is going to be played by a male actor, and the part of a child is going to be played by a child actor. So the question is, how many different possible ways can this family be cast? All right, so the thing to realize, mathematics is a lot about ignoring details that don't matter and seeing the underlying structure of the problem that's affecting what you care about. And here we care about the number of possibilities for counting something. So these are actually the exact same problem, and I think that you'll see that once we start to solve them. So for the triangle one, you could break this down into a fundamental counting principle problem by thinking about, all right, if I'm going to make a triangle, it has to have 3 sides. So how many ways could I choose the first side and the second side and the third side? Clearly, I can't choose 2 sides to be parallel to each other because then it won't make a triangle. So I know one of my sides has to be from these 2, one of my sides has to be from these 4, and one has to be from these 3. So the number of ways to choose my first side, let's say there's 2 ways because it's going to be one of these 2. And the next one, let's say there's 4 ways to choose the next side, and then 3. So that's going to give me 24 triangles in this diagram. And that's nice, because now I don't have to count each one up separately. See, I told you the subject was about counting. Okay, so let's do this one. So I'm choosing 2 female actors, 3 male, and 2 child actors. Well, what if these 2 lines represent the female actors? And what if these 3 lines here represent the male actors? And what if these 4 lines represent the child actors? If I'm going to cast each of these parts, I need to choose one of the 2 female actors, one of the 4 child actors, and one of the 3 male actors. So if I break this down into a fundamental counting principle, there's 2 choices for my female actor, there's 4 choices for my child actor, and there's 3 choices for my male actor. And that gives me 24 possible casts. So another example of how the counting problem may require you to think a little bit about what is it exactly that we're choosing in order to construct the possibilities that we're trying to count. All right, less problems. So there's 4 cities, A, B, C, and D. Let's say there are 4 roads that you can travel from city A to city B on. If you want to go from city B to city C, there are 3 roads. If you want to travel from A to D, there are 5 roads that do that. And if you want to travel from D to C, there are 5 roads that do that. And the question is, how many different ways are there to travel from city A to city C? I would encourage you to pause the video and give this a try yourself. Go ahead, give it a pause. I certainly hope that you made some visualization for yourself like this to help make sense of the problem. Once you actually visualize it, it's pretty clear if you're going from A to C, you've either got to go through city B or you've got to go through city D. So this is a situation where we have to use some common sense along with the fundamental counting principle. Always a good idea to use the common sense. So if we're looking at how many total routes from A to C through city B, we got to choose one of these roads and one of those roads. So that's four options for the first road and then 3 options for the next road here. So that's 12 possible routes if we go this direction. If we go this direction, I got to choose one of these roads and one of those roads, and there's 5 and 5 of them. So that's 5 times 5 is 25 routes. So this is going through city B, this is going through city D. So how many routes are there total? 25 plus 12 is 37 routes total. So like I said, you can use the fundamental counting principle, but every problem is likely to be slightly different than every other problem, and the only way to get it right is by using your common sense and asking yourself, what am I really trying to count here? And then, what choices am I making, and how many options do I have? Okay, I hope this has been helpful. Come on back next time for a derivation of the combinations formula.